What if everything you know about reality is just a tiny fraction of what truly exists? What if beyond the stars and galaxies we see, there are countless other universes, each with its own set of rules, its own version of history, and maybe even its own version of you? This isn't science fiction, it's a possibility that some of the brightest minds in science are taking seriously. The idea of parallel universes, once relegated to the realm of imagination, is now a topic of serious scientific debate. From the mind-bending principles of quantum mechanics to the vast mysteries of cosmic inflation, scientists are uncovering clues that suggest our universe might be just one of many in an infinite multiverse. But why are they so convinced? What evidence could possibly support such an extraordinary idea? In this video, we'll dive into 25 compelling reasons why scientists believe in parallel universes. From the strange behavior of particles at the quantum level to the mind-blowing implications of string theory, we'll explore the theories, the evidence, and the questions that keep pushing the boundaries of our understanding. So buckle up, because by the end of this journey, you might just find yourself questioning everything you thought you knew about reality. Let's begin. Now, turning to the first reason scientists believe in parallel universes, we dive into the fascinating world of quantum mechanics. At the heart of this theory lies the many worlds interpretation, a mind-bending idea that suggests every quantum decision creates a new universe. Imagine this: when a particle is in a state of superposition, it exists in multiple states at once, like being in two places simultaneously. But when we observe it, the wave function collapses and the particle chooses one state. The many worlds interpretation takes this a step further, proposing that instead of collapsing, the wave function branches off, creating a new universe for every possible outcome. This means that every decision, no matter how small, could spawn an entirely new reality. From the flip of a coin to the path of an electron, the possibilities are endless, leading to the idea of infinite parallel universes coexisting alongside our own. It's a concept that challenges our understanding of reality and opens the door to a multiverse where every possible outcome plays out somewhere. Now, turning to the second reason scientists believe in parallel universes, we explore the theory of cosmic inflation. This groundbreaking idea suggests that in the moments following the Big Bang, the universe underwent an incredibly rapid expansion, stretching far faster than the speed of light. But what does this have to do with parallel universes? Well, during this explosive growth, tiny quantum fluctuations, those random microscopic changes in energy, were stretched to enormous scales. These fluctuations could have created regions of space that stopped inflating at different times, forming isolated bubble universes within a larger multiverse. Each of these bubbles could have its own unique set of physical laws, constants, and even dimensions, making them entirely separate from our own universe. Picture it like a cosmic foam, where each bubble is a self-contained universe, floating in an endless sea of possibilities. This theory not only explains the uniformity of our universe, but also opens the door to the existence of countless other universes, each with its own story to tell. It's a mind-blowing concept that reshapes how we think about the cosmos and our place within it. Now, turning to the third reason scientists believe in parallel universes, we delve into the fascinating world of string theory. This revolutionary framework suggests that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. These strings oscillate in multiple dimensions, not just the 3 spatial dimensions we experience, but as many as 10 or 11. But why does this matter for parallel universes? Well, these extra dimensions could be hiding entire universes, folded and compacted in ways we can't perceive. Imagine our universe as a sheet of paper, but stacked alongside countless other sheets, each representing a different universe. String theory not only proposes the existence of these hidden dimensions, but also attempts to unify all the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces into a single, elegant framework. This unification hints at a deeper connection between all things, suggesting that our universe might just be one thread in a vast cosmic tapestry. By exploring string theory, scientists are uncovering a potential roadmap to the multiverse, where parallel realities could exist just beyond our reach, waiting to be discovered. Now turning to the fourth reason scientists believe in parallel universes, we explore the mathematical consistency of multiverse theories. At the heart of these theories lies a foundation of robust and elegant mathematics, which not only supports their plausibility but also makes them compelling to researchers. Take quantum mechanics, for example. Its equations describe the behavior of particles in ways that are incredibly precise, yet they also suggest the existence of multiple outcomes for every event. The many worlds interpretation, a key idea in quantum mechanics, relies on these equations to propose that every possible outcome of a quantum event spawns a new universe. Similarly, string theory, with its intricate mathematical framework, predicts the existence of extra dimensions and parallel universes. These theories are not just speculative ideas, they are grounded in mathematical models that have been rigorously tested and refined over decades. What's fascinating is that these models remain consistent even when applied to the concept of a multiverse. While we may not yet have the technology to observe parallel universes directly, the mathematics behind these theories provides a strong case for their existence. It's like having a map to a hidden treasure. Even if we can't see the treasure yet, the map tells us it's there. This mathematical consistency is one of the key reasons scientists continue to explore the possibility of parallel universes, pushing the boundaries of our understanding of reality. Now turning to the fifth reason scientists believe in parallel universes, we delve into the fine-tuning problem. This concept revolves around the idea that the fundamental constants of nature, like the strength of gravity, the speed of light, and the charge of an electron, are perfectly calibrated to allow life to exist. If any of these constants were even slightly different, the universe as we know it would be unrecognizable, and life as we understand it would be impossible. For example, if gravity were just a tiny bit stronger, stars would burn out too quickly, leaving no time for planets to form or life to evolve. On the other hand, if gravity were weaker, stars might not form at all. This precise balance has led scientists to wonder, why is our universe so perfectly tuned for life? One compelling explanation is the multiverse theory. If there are countless universes, each with its own set of physical constants, it's statistically inevitable that at least one of them would have the right conditions for life. In this scenario, our universe isn't special, it's just one of many, and we happen to live in the one where everything aligns perfectly for our existence. This idea not only solves the fine-tuning problem, but also provides a natural explanation for why our universe seems so uniquely suited for life. It's like winning the cosmic lottery, except in a multiverse someone has to win. This elegant solution is another reason why scientists are increasingly drawn to the idea of parallel universes, as it offers a way to make sense of the seemingly miraculous conditions that make life possible. Now turning to the sixth reason scientists believe in parallel universes, we explore the Boltzmann Brain Paradox. This intriguing concept challenges our understanding of why the universe appears so orderly and structured, rather than being a chaotic mess of random fluctuations. According to the laws of thermodynamics, the most likely state of the universe is one of maximum entropy or disorder. So why do we observe such a high level of order, from the formation of galaxies to the intricate structures of life? The Boltzmann Brain Paradox suggests that, statistically, it's far more likely for a single, self-aware brain to spontaneously form out of random fluctuations than for an entire ordered universe to exist. In other words, if the universe were truly random, we should expect to find isolated, conscious entities like a lone brain floating in the void rather than the vast, interconnected cosmos we see around us. This paradox has puzzled scientists for decades, but the multiverse theory offers a potential solution. If our universe is just one of countless others in a vast multiverse, it's possible that most of these universes are chaotic and disordered, while a rare few, like ours, are structured and stable. In this scenario, our ordered existence isn't a statistical anomaly, but rather a natural outcome of the multiverse's diversity. The multiverse provides a context for why we perceive an ordered universe, as it allows for the existence of pockets of stability within a larger, chaotic framework. This idea not only resolves the Boltzmann Brain Paradox, but also reinforces the plausibility of parallel universes, offering a compelling explanation for the order we observe in our own reality. It's a fascinating reminder that even the most perplexing questions about the universe might find their answers in the vast, interconnected tapestry of the multiverse. Now turning to the seventh reason scientists believe in parallel universes, we delve into the simulation hypothesis. This provocative idea suggests that our universe might not be the base reality, but rather an incredibly advanced simulation, akin to a highly sophisticated computer program. If this is true, it opens the door to the possibility of countless simulated parallel universes, each running its own unique set of rules and realities. The simulation hypothesis is rooted in the idea that future civilizations could develop technology so advanced that they could create entire universes within simulations, complete with conscious beings who perceive their reality as real. Philosophers like Nick Bostrom have argued that if such simulations are possible, it's statistically more likely that we are living in one rather than in the original, base reality. From a scientific perspective, some researchers have proposed that if our universe is a simulation, there might be subtle glitches or patterns in the fabric of reality that could serve as evidence. For example, anomalies in the behavior of particles or the fine-tuning of physical constants might hint at the underlying code of the simulation. However, critics of the simulation hypothesis point out that it's difficult, if not impossible, to test or prove definitively. They argue that the idea leans more toward philosophy than science, as it lacks concrete evidence and relies heavily on speculation. Despite these challenges, the simulation hypothesis remains a fascinating topic that bridges science, philosophy, and technology. If true, it would not only imply the existence of parallel universes, but also fundamentally alter our understanding of reality itself. Whether we're living in a simulation or not, the idea invites us to question the nature of existence and consider the profound implications of a multiverse where countless realities might coexist, each as real to its inhabitants as our own is to us. Now turning to the eighth reason scientists believe in parallel universes, we explore the intriguing concept of black hole cosmology. Black holes, those mysterious regions of space where gravity is so intense that nothing, not even light, can escape, might hold the key to understanding the existence of other universes. According to some theories, the singularity at the heart of a black hole, a point where density becomes infinite and the laws of physics as we know them break down, could be the birthplace of an entirely new universe. This idea suggests that when matter is crushed to an unimaginable density within a black hole, it might trigger the creation of a new reality, complete with its own set of physical laws and dimensions. In this scenario, our universe could be just one of many, each connected through a vast network of black holes acting as cosmic gateways. Some scientists propose that the Big Bang itself, which gave birth to our universe, might have been the result of a singularity in a black hole from another universe. This theory, known as black hole cosmology, offers a fascinating perspective on the origins of our universe and the possibility of a multiverse. While this idea is still speculative and lacks direct evidence, it provides a compelling framework for understanding how black holes could serve as bridges between parallel realities. The concept also raises profound questions about the nature of existence and the interconnectedness of all things. If black holes truly are gateways to other universes, they could be the ultimate cosmic portals, linking countless realities in an infinite web of creation and destruction. As we continue to study these enigmatic objects, we may uncover clues that bring us closer to understanding whether our universe is just one thread in a much larger cosmic tapestry. Now turning to the ninth reason scientists believe in parallel universes, we delve into the holographic principle, a mind-bending concept that challenges our understanding of reality itself. This principle suggests that our three-dimensional universe might actually be a projection from a two-dimensional surface, much like a hologram. Imagine a movie screen projecting a three-dimensional image. Our universe could work in a similar way, with all the information about space, time, and matter encoded on a flat, lower-dimensional boundary. This idea stems from the study of black holes, where scientists discovered that the information about everything that falls into a black hole is somehow preserved on its surface, known as the event horizon. If this principle holds true for the entire universe, it could mean that everything we see, touch, and experience is essentially a holographic projection from the edges of our reality. But how does this connect to parallel universes? Some theories propose that these lower dimensional boundaries could encode not just our universe but countless others. Each universe might exist as a separate projection, like different channels on a television, all emanating from the same underlying surface. This would mean that parallel universes could be layered within the same holographic framework, each with its own unique set of physical laws and dimensions. The holographic principle also raises fascinating questions about the nature of reality. If our universe is a projection, what lies beyond the screen? Could there be other projections, other universes, existing alongside ours? While this idea is still theoretical, it offers a radical new way to think about the cosmos and our place within it. As we continue to explore the implications of the holographic principle, we may uncover clues that bring us closer to understanding whether our reality is just one of many in a vast, multidimensional hologram. Now turning to the 10th reason scientists believe in parallel universes, we explore the anthropic principle, a fascinating idea that ties the existence of life directly to the nature of the universe itself. The anthropic principle suggests that the universe must have properties that allow for the existence of conscious observers like us. In other words, the conditions of our universe are finely tuned to support life, and if they were even slightly different, life as we know it wouldn't exist. But why is this the case? Why does the universe seem so perfectly calibrated for life? This is where the multiverse theory comes into play. If there are countless parallel universes, each with its own unique set of physical laws and constants, it's statistically inevitable that at least one of them would have the right conditions for life to emerge. In this vast multiverse, universes with incompatible laws might exist, but they would remain barren, devoid of observers. Only in universes like ours, where the constants of nature, such as the strength of gravity or the charge of an electron, are just right, could life arise and evolve. This means that the anthropic principle doesn't require our universe to be special or uniquely designed. Instead, it's simply one of many possible universes, and we happen to live in one that supports our existence. The multiverse provides a natural explanation for why our universe appears so finely tuned. It's not that the universe was made for us, but rather, we exist because the universe has the right conditions. This idea shifts the perspective from asking why our universe is the way it is, to recognizing that in a multiverse, every possible configuration of physical laws exists somewhere. As we continue to explore the implications of the anthropic principle, it opens up profound questions about our place in the cosmos. Are we just one of countless civilizations scattered across a multiverse, each observing their own unique universe, or is there something deeper at play? The anthropic principle, combined with the multiverse theory, offers a compelling framework for understanding why we find ourselves in a universe that seems tailor-made for life. Now turning to the 11th reason scientists believe in parallel universes, we delve into the evidence found in the cosmic microwave background, or CMB. The CMB is the afterglow of the Big Bang, a faint radiation that fills the universe and provides a snapshot of the cosmos when it was just 380,000 years old. This ancient light holds clues about the early universe, and some of these clues have sparked intriguing theories about the multiverse. One of the most compelling pieces of evidence comes from anomalies observed in the CMB. These anomalies are irregularities in the temperature and distribution of the radiation that don't quite fit with our standard models of the universe. Some scientists propose that these irregularities could be the result of collisions between our universe and other bubble universes. Imagine our universe as one bubble in a vast cosmic foam, where each bubble represents a separate universe with its own physical laws. If two bubbles were to collide, the impact could leave a mark on the CMB, creating patterns or cold spots that we can observe today. These collisions would be like cosmic fingerprints, evidence of interactions between parallel universes. While this idea is still speculative, it offers a tantalizing possibility. If these anomalies are indeed signs of collisions with other universes, they could provide the first direct evidence of the multiverse. This would revolutionize our understanding of reality, showing that our universe is just one of many in a grand cosmic tapestry. The implications of such a discovery are profound. It would mean that the multiverse isn't just a theoretical concept, but a physical reality with observable consequences. As scientists continue to analyze the CMB with increasingly precise instruments, they hope to uncover more clues that could confirm or refute these ideas. The search for evidence of parallel universes in the CMB is a reminder of how much we still have to learn about the cosmos. It challenges us to think beyond the boundaries of our own universe and consider the possibility that we are part of something far greater. What other secrets might the CMB hold? Could it reveal not just the origins of our universe, but the existence of countless others? These questions drive the ongoing quest to understand the true nature of reality. Now turning to the 12th reason scientists believe in parallel universes, we explore the fascinating concept known as the landscape of string theory. String theory is one of the most ambitious attempts to unify all the fundamental forces of nature, and it proposes that the universe is made up of tiny, vibrating strings. But what makes string theory particularly intriguing is its suggestion of a vast landscape of possible vacuum states. These vacuum states represent different configurations of the universe, each with its own unique set of physical laws and constants. In fact, string theory predicts that there could be as many as 10 to the power of 500 possible vacuum states. That's an unimaginably large number, far exceeding the number of atoms in the observable universe. Each of these vacuum states corresponds to a different universe, meaning that within the framework of string theory, there could be an almost infinite variety of parallel universes, each with its own distinct properties. Some of these universes might have stronger gravity, others might have different particle interactions, and some might even have entirely new forces that don't exist in our own universe. This vast landscape of possibilities provides a compelling explanation for why our universe has the specific laws and constants that it does. If there are countless universes with different physical laws, it's not surprising that at least one of them would have the right conditions for life to emerge. The landscape of string theory also offers a potential solution to the fine-tuning problem, which we discussed earlier. Instead of asking why our universe is so finely tuned for life, we can consider that life simply arises in the universes where the conditions are right. This idea shifts the focus from why our universe is special to why we find ourselves in this particular universe out of so many possibilities. While the landscape of string theory is still a theoretical framework, it has profound implications for our understanding of reality. It suggests that the multiverse isn't just a collection of similar universes, but a diverse and complex array of realities, each governed by its own unique rules. As scientists continue to explore the implications of string theory, they hope to uncover more evidence that could shed light on this cosmic landscape. The idea of a multiverse with 10 to the power of 500 possible universes challenges us to rethink our place in the cosmos. It invites us to consider that our universe might be just one tiny corner of a much larger, more intricate reality. What other wonders might exist in this vast landscape, and what does it mean for our understanding of existence itself? These are the questions that drive the ongoing exploration of string theory and its implications for the multiverse. Now turning to the 13th reason scientists believe in parallel universes, we delve into the mysterious phenomenon of quantum entanglement. Quantum entanglement occurs when two or more particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. This connection defies our everyday understanding of space and time, as the particles seem to communicate faster than the speed of light. But what if this strange behavior isn't just a quirk of our universe? What if it's a clue that these particles are somehow connected across different realities? Some scientists have proposed that entangled particles might not just be linked across vast distances within our universe, but could also be tied to particles in parallel universes. This idea suggests that the entanglement we observe might be a glimpse into a deeper, hidden structure of reality, one where multiple universes are intertwined. Imagine two particles entangled across parallel realities. A change in one particle in our universe could instantly affect its counterpart in another universe, even though the two universes are completely separate. This theory opens up the possibility that parallel universes aren't entirely isolated, but could be subtly connected through these quantum links. While this idea is still speculative, it offers a fascinating way to think about the nature of entanglement and the multiverse. If true, it would mean that the boundaries between universes might not be as rigid as we once thought. Instead, there could be a hidden web of connections weaving through the fabric of reality, linking countless universes together. This concept also raises intriguing questions about the nature of information and communication. Could entanglement be a way for information to travel between universes? And if so, what kind of information might be exchanged? These questions push the boundaries of our understanding and challenge us to rethink what we know about the universe or universes we inhabit. As researchers continue to explore the mysteries of quantum entanglement, they hope to uncover more clues about its potential connection to parallel realities. The quantum entanglement paradox not only deepens our understanding of the quantum world, but also invites us to consider the possibility that our universe is just one thread in a vast, interconnected multiverse. What other secrets might entanglement reveal about the nature of existence, and how might these discoveries reshape our understanding of reality itself? These are the questions that drive the ongoing exploration of quantum entanglement and its implications for the multiverse. Now turning to the 14th reason scientists believe in parallel universes, we explore the enigmatic force known as dark energy. Dark energy is the mysterious energy that makes up about 68% of the universe and is responsible for its accelerating expansion. But what if this force isn't just shaping our universe? What if it's also playing a role in creating entirely new ones? Some theories suggest that dark energy could be the driving force behind the formation of bubble universes within a larger multiverse. Imagine the universe as a vast ocean, with dark energy acting like the currents that push and pull at the fabric of space. In this scenario, regions of space could expand so rapidly that they pinch off, forming isolated bubbles that become their own separate universes. Each of these bubble universes would have its own unique properties, governed by different physical laws and constants. This idea ties dark energy directly to the concept of a multiverse, suggesting that the same force causing our universe to expand could also be spawning countless others. But how does this work? One theory proposes that dark energy creates regions of space where the expansion becomes so intense that it triggers a kind of cosmic budding, where new universes are born from the rapid stretching of space-time. These new universes would then continue to expand, potentially creating even more bubbles in an endless cycle. This process, known as eternal inflation, could explain why our universe appears so finely tuned for life. In a multiverse filled with countless bubble universes, it's statistically inevitable that at least one would have the right conditions for life to emerge. Dark energy, in this context, becomes not just a mysterious force but a cosmic architect, shaping the structure of reality on the grandest scale. While this idea is still speculative, it offers a compelling way to think about the role of dark energy in the cosmos. If true, it would mean that the expansion of our universe is just one small part of a much larger, more complex process, one that could be creating new universes all the time. As scientists continue to study dark energy and its effects, they hope to uncover more clues about its potential connection to parallel universes. Could dark energy be the key to understanding the multiverse? And if so, what does that mean for our place in the cosmos? These are the questions that drive the ongoing exploration of dark energy and its role in the grand tapestry of existence. Now turning to the 15th reason scientists believe in parallel universes, we delve into the intriguing concept known as the brain world scenario. This theory proposes that our universe is not just a three-dimensional space, but rather a three-dimensional brain, floating within a higher dimensional space, often referred to as the bulk. Imagine our universe as a thin sheet of paper drifting in a vast, multidimensional ocean. This sheet, or brain, exists alongside other brains, each potentially hosting its own universe with its own set of physical laws and constants. But what happens when these brains collide? According to the brain world scenario, such collisions could be the birthplaces of entirely new universes. Picture two sheets of paper floating in the air, slowly moving toward each other. When they meet, the impact could create ripples of energy so immense that they give rise to a new universe. This idea suggests that the Big Bang, which marked the beginning of our universe, might have been the result of a collision between two brains in this higher dimensional space. These collisions wouldn't just be one-time events. In a multiverse filled with countless brains, such interactions could happen repeatedly, leading to the creation of multiple universes over time. Each new universe would inherit its own unique properties from the energy and dynamics of the collision, resulting in a diverse multiverse with an endless variety of physical laws and conditions. The brain world scenario also provides a framework for understanding why our universe appears so finely tuned for life. In a multiverse where countless universes are born from brain collisions, it's statistically likely that at least one would have the right conditions to support life. This theory not only offers a fascinating explanation for the origins of our universe, but also suggests that parallel universes could be a natural consequence of the structure of higher dimensional space. While the brain world scenario remains speculative, it has gained traction among physicists as a compelling way to explore the nature of reality. By studying the potential interactions between brains, scientists hope to uncover more clues about the existence of parallel universes and the fundamental structure of the cosmos. Could our universe be just one of many brains floating in a higher dimensional sea? And if so, what other universes might exist alongside ours, shaped by their own unique collisions? These are the questions that drive the ongoing exploration of the brain world scenario and its implications for the multiverse. Now turning to the 16th reason scientists believe in parallel universes, we explore the concept of eternal inflation. This theory suggests that the universe doesn't just expand once, as in the Big Bang, but undergoes endless cycles of expansion, creating a never-ending cascade of new universes. Imagine a balloon that keeps inflating, but instead of just one balloon, there are countless balloons, each representing a new universe. As the original balloon expands, smaller bubbles form within it, each growing into its own universe with its own unique properties. These bubble universes are born from the rapid expansion of space itself, driven by a mysterious force known as inflation. In this scenario, inflation doesn't stop after the Big Bang. Instead, it continues in certain regions of space, creating pockets where new universes are constantly being born. Each of these universes could have different physical laws, constants, and even dimensions, leading to an infinite variety of realities. The eternal inflation theory provides a natural explanation for why our universe appears so finely tuned for life. In an infinite multiverse, every possible combination of physical laws and constants would exist somewhere. It's no surprise, then, that we find ourselves in a universe where the conditions are just right for life to emerge. This theory also helps resolve some of the biggest questions in cosmology, such as why the universe is so uniform on large scales. The rapid expansion during inflation would smooth out any irregularities, creating the even distribution of matter and energy we observe today. While eternal inflation remains a theoretical framework, it has gained significant support among physicists for its ability to explain the origins of our universe and the potential existence of parallel universes. By studying the mechanisms of inflation, scientists hope to uncover more evidence for this theory and, by extension, the multiverse. Could our universe be just one of countless bubbles in an ever-expanding cosmic ocean? And if so, what other realities might exist beyond the boundaries of our own? These are the questions that drive the ongoing exploration of eternal inflation and its implications for the nature of existence. Now turning to the 17th reason scientists believe in parallel universes, we delve into the quantum suicide thought experiment. This mind-bending concept takes the idea of the multiverse to a deeply personal level, exploring what it means to exist across infinite realities. Imagine a scenario where a person is placed in a situation where their survival depends on a random quantum event, like the decay of a radioactive atom. In one universe, the atom decays and the person does not survive. But in another universe, the atom does not decay and the person lives. According to the many worlds interpretation of quantum mechanics, both outcomes happen simultaneously, creating two separate universes, one where the person dies and one where they live. The quantum suicide thought experiment suggests that, from the perspective of the observer, they will always find themselves in a universe where they survive. No matter how many times the experiment is repeated, the observer will only experience the outcomes where they continue to exist. This leads to the bizarre conclusion that, in a multiverse, there are always universes where the observer is alive, no matter how unlikely the odds. This thought experiment highlights the strange and counterintuitive nature of parallel universes, where every possible outcome of every event exists somewhere in the multiverse. It also raises profound questions about consciousness and identity. If there are infinite versions of ourselves across different universes, which one is the real us? And how do we reconcile the idea that our existence is just one thread in an infinite tapestry of possibilities? While the quantum suicide thought experiment is purely theoretical, it serves as a powerful tool for exploring the implications of the multiverse. It challenges our understanding of reality and forces us to confront the idea that our lives might be just one of countless versions playing out across the cosmos. Could it be that, in some other universe, a version of you is living a completely different life? And if so, what does that mean for the choices we make in this one? These are the kinds of questions that make the quantum suicide thought experiment not just a scientific curiosity, but a gateway to deeper philosophical reflection on the nature of existence itself. Now turning to the 18th reason scientists believe in parallel universes, we explore the fascinating connection between quantum computing and the multiverse. Quantum computers, unlike classical computers, operate using the principles of superposition and entanglement, two cornerstones of quantum mechanics that also underpin the idea of parallel universes. In a quantum computer, qubits can exist in multiple states simultaneously, thanks to superposition. This means that a quantum computer can perform many calculations at once, exploring countless possibilities in parallel. But here's where it gets mind-blowing. Some scientists suggest that this parallel processing might not just be happening within the computer, it could be happening across multiple universes. The idea is that every time a quantum computer performs a calculation, it's not just exploring different outcomes within our universe, it's potentially tapping into the computational power of other universes. In other words, the quantum computations we observe might be the result of interactions between our universe and countless others. This theory aligns with the many worlds interpretation, which suggests that every quantum decision spawns a new universe. If that's the case, then quantum computers could be inadvertently providing indirect evidence for the existence of parallel universes. But how does this work in practice? Imagine a quantum computer solving a complex problem. As it processes information, it's not just crunching numbers in isolation, it's leveraging the infinite possibilities of the multiverse. Each possible outcome of the computation could correspond to a different universe, and the computer's final result might be a combination of all these parallel realities. This raises the tantalizing possibility that quantum computers are not just tools for solving problems, they might also be windows into the multiverse. Of course, this idea is still speculative, and there's much we don't yet understand about how quantum computing and parallel universes might be connected. But the very fact that quantum computers rely on the same principles that suggest the existence of a multiverse is enough to spark curiosity and debate. Could quantum computing one day provide concrete evidence for parallel universes? And if so, what would that mean for our understanding of reality? These are questions that push the boundaries of science and philosophy, reminding us that the multiverse isn't just a theoretical concept, it's a frontier waiting to be explored. Now turning to the 19th reason scientists believe in parallel universes, we delve into the intriguing role of consciousness in the multiverse. At the heart of this idea is the observer effect in quantum mechanics, which suggests that the act of observation can influence the outcome of a quantum event. This phenomenon has led some scientists to propose that consciousness itself might play a crucial role in determining which universe we experience. Imagine this: every time a quantum event occurs, such as the decay of a radioactive atom, multiple outcomes are possible. According to the many worlds interpretation, each possible outcome spawns a new universe, but here's where consciousness comes into play. Some theories suggest that our conscious observation of an event might collapse the wave function, locking us into one specific outcome and thus one specific universe. In other words, our awareness could be the key that determines which parallel reality we inhabit. This idea raises profound questions about the nature of reality and our place within it. If consciousness influences which universe we experience, does that mean there are other versions of us experiencing different outcomes in other universes? Could our thoughts and observations be shaping not just our own reality, but the entire multiverse? These questions blur the line between science and philosophy, challenging us to rethink the relationship between mind and matter. One of the most fascinating aspects of this theory is its potential to explain why we perceive an ordered, stable universe despite the chaotic nature of quantum mechanics. If consciousness acts as a filter, selecting one universe out of countless possibilities, it could provide a framework for understanding why our reality appears so consistent. This idea also aligns with the anthropic principle, which suggests that the universe must be compatible with the conscious life that observes it. Of course, the role of consciousness in the multiverse remains a highly speculative and controversial topic. While some scientists see it as a compelling explanation for the observer effect, others argue that it ventures too far into the realm of metaphysics. Still, the very possibility that our minds might be intertwined with the fabric of the multiverse is a thought-provoking concept that pushes the boundaries of both science and imagination. As we continue to explore the mysteries of quantum mechanics and parallel universes, the role of consciousness remains a tantalizing puzzle. Could our awareness be the thread that connects us to the infinite tapestry of the multiverse? And if so, what does that mean for our understanding of existence itself? These are questions that remind us just how strange and wondrous the cosmos truly is. Now turning to the 20th reason scientists believe in parallel universes, we explore the fascinating implications of time travel. The idea of traveling through time has long captured the imagination of both scientists and storytellers. But what if time travel isn't just a journey through history? What if it's a journey into another universe? This is where the concept of parallel universes comes into play. Imagine this: you step into a time machine and travel back to a pivotal moment in history. According to some theories, your arrival in the past wouldn't just alter the timeline of your own universe, it could create an entirely new one. This is known as the branching timeline theory, which suggests that any change made in the past would cause the timeline to split, creating a parallel universe where the altered events unfold. In this new universe, the consequences of your actions would play out independently of the original timeline, effectively spawning a new reality. This idea is closely tied to the many worlds interpretation of quantum mechanics, which proposes that every decision or event creates a new universe. In the context of time travel, every change made in the past could be seen as a quantum event, triggering the creation of a parallel universe. For example, if you traveled back in time and prevented a historical event, the original timeline would continue to exist, but a new universe would emerge where that event never occurred. This means that time travel wouldn't just rewrite history, it would multiply it. But how does this connect to the multiverse? If time travel creates new timelines, then the multiverse could be seen as a vast network of branching realities, each one the result of a different sequence of events. Some scientists even speculate that every possible outcome of every possible event exists somewhere in the multiverse, meaning that every decision you've ever made or could have made has spawned its own parallel universe. This raises mind-bending questions about free will, destiny, and the nature of reality itself. Of course, the idea of time travel creating parallel universes remains speculative, as time travel itself is still a theoretical concept. However, it provides a compelling framework for understanding how the multiverse might operate. If time travel were possible, it could offer a way to explore not just different points in history, but different realities altogether. And while we may not have the technology to build a time machine yet, the very possibility that time travel could spawn parallel universes reminds us just how interconnected and complex the cosmos might be. As we ponder the implications of time travel, we're left with a profound question. If every choice we make creates a new universe, how many versions of ourselves are out there, living out the consequences of decisions we never made? And what does that mean for our understanding of identity, responsibility, and the nature of existence? These are questions that challenge us to think beyond the boundaries of our own reality and consider the infinite possibilities of the multiverse. Now turning to the 21st reason scientists believe in parallel universes, we delve into the Fermi paradox and its intriguing connection to the multiverse. The Fermi paradox poses a simple yet profound question. If the universe is so vast and filled with countless stars and planets, why haven't we encountered any signs of extraterrestrial life? This paradox has puzzled scientists for decades, but the multiverse theory might offer a compelling explanation. Imagine a universe where the conditions for life are incredibly rare. In such a universe, intelligent civilizations might be so isolated that they never cross paths. But what if our universe is just one of many, each with its own unique set of physical laws and conditions? In this scenario, life might flourish in some universes while being entirely absent in others. The multiverse could explain why we haven't found extraterrestrial life, because life simply doesn't exist in our particular universe, or at least not in a form we can detect. This idea ties into the concept of the anthropic principle, which suggests that the universe we observe must be compatible with the existence of conscious life. If there are countless universes, each with different physical constants and laws, it's possible that only a small fraction of them have the right conditions to support life. In other words, we might be living in one of the rare universes where life is possible, while the vast majority of universes remain lifeless. This would explain why, despite the immense size of our universe, we seem to be alone. But the multiverse theory doesn't just explain the absence of extraterrestrial life, it also raises fascinating possibilities about where life might exist. If there are infinite parallel universes, some of them could be teeming with civilizations far more advanced than our own. These universes might have entirely different forms of life, governed by different physical laws, existing in ways we can't even imagine. The multiverse opens up a realm of possibilities that challenges our understanding of life and its potential forms. Of course, the Fermi paradox and the multiverse theory remain speculative, but they provide a thought-provoking framework for exploring the mysteries of existence. If life is abundant in some universes and absent in others, what does that mean for our place in the cosmos? Are we alone in our universe, or are we simply unable to detect the life that exists elsewhere? These questions remind us of the vastness and complexity of the multiverse and the endless possibilities it holds for discovery. As we consider the Fermi paradox in the context of the multiverse, we're left with a profound realization. The search for extraterrestrial life isn't just about finding other civilizations, it's about understanding the nature of reality itself. And if the multiverse is real, then the answers to these questions might lie not just in our universe, but in the infinite array of parallel realities that exist alongside it. Now turning to the 22nd reason scientists believe in parallel universes, we explore the fascinating role of symmetry in physics and how it might hint at the existence of other realities. Symmetry is a fundamental concept in the universe, governing everything from the behavior of particles to the structure of galaxies. But what if these symmetries or their breakdowns could reveal something even more profound, like the presence of parallel universes? One of the most intriguing symmetries in physics is charge parity symmetry, often referred to as CP symmetry. This principle suggests that the laws of physics should remain the same if particles are replaced with their antiparticles and their spatial coordinates are mirrored. However, experiments have shown that CP symmetry is not perfectly preserved in certain particle interactions, a phenomenon known as CP violation. This broken symmetry has puzzled scientists for decades, but some theories propose that it could be evidence of interactions between our universe and parallel ones. Imagine a scenario where the forces governing our universe are subtly influenced by neighboring realities. These interactions could cause slight deviations in the symmetries we observe, like CP violation. In other words, the broken symmetries in our universe might be the fingerprints of parallel universes brushing up against our own. This idea suggests that the multiverse isn't just a collection of isolated realities, but a network of interconnected worlds, each influencing the others in ways we're only beginning to understand. Another example lies in the concept of supersymmetry, a theoretical framework that proposes a symmetry between particles and their superpartners. While supersymmetry has yet to be confirmed experimentally, some physicists believe that its potential discovery could provide clues about the existence of higher dimensional spaces or parallel universes. If supersymmetry is real, it might imply that our universe is just one layer of a much larger, multidimensional reality. The role of symmetry in physics doesn't just deepen our understanding of the universe, it also opens the door to new possibilities about the nature of reality itself. If broken symmetries are indeed evidence of interactions between universes, then the multiverse might be far more interconnected than we ever imagined. These subtle connections could be the key to unlocking some of the greatest mysteries in science, from the origins of the universe to the fundamental forces that shape it. As we delve into the role of symmetry in the multiverse, we're reminded that even the most fundamental principles of physics might hold clues to realities beyond our own. The search for symmetry and its breakdowns isn't just about understanding our universe, it's about exploring the infinite possibilities that lie within the multiverse. And if these theories are correct, then the answers to some of our biggest questions might be hidden in the delicate balance of symmetries that govern the cosmos. Now turning to the 23rd reason scientists believe in parallel universes, we dive into the fascinating world of particle colliders and how these incredible machines might hold the key to uncovering evidence of other realities. Particle colliders, like the Large Hadron Collider, are designed to smash particles together at incredibly high speeds, recreating conditions similar to those just moments after the Big Bang. But what if these collisions could do more than just reveal the secrets of our universe? What if they could provide clues about the existence of parallel universes? One of the most intriguing possibilities is that high-energy collisions in particle colliders could create micro-black holes. These tiny black holes, if detected, might not just be a curiosity, they could be evidence of extra dimensions, a key prediction of string theory. According to some theories, our universe might be a three-dimensional brain floating in a higher dimensional space. If these extra dimensions exist, then the energy from particle collisions could momentarily create a black hole that exists in those higher dimensions. While these micro-black holes would evaporate almost instantly, their detection would be a groundbreaking discovery, suggesting that our universe is just one layer of a much larger, multidimensional reality. Another exciting possibility is that particle colliders could reveal the presence of hidden particles or forces that don't belong to our universe but instead originate from parallel ones. For example, some theories propose that dark matter, the mysterious substance that makes up most of the universe's mass, might actually be ordinary matter from a parallel universe that interacts with ours only through gravity. If particle colliders could detect particles that behave in unexpected ways, it might hint at the influence of these hidden realities. The Large Hadron Collider has already made groundbreaking discoveries such as the Higgs boson, but its potential to uncover evidence of parallel universes is still largely untapped. Scientists are constantly refining their experiments, searching for anomalies that could point to the existence of extra dimensions, micro-black holes, or even particles from other universes. While these discoveries remain speculative, the very possibility that particle colliders could reveal the multiverse is a thrilling prospect. As we explore the evidence from particle colliders, we're reminded that the search for parallel universes isn't just about looking beyond the stars. It's also about peering into the smallest building blocks of reality. The collisions happening in these massive machines might hold the key to unlocking some of the greatest mysteries of the cosmos, from the nature of dark matter to the existence of higher dimensions. And if these experiments succeed, they could provide the first tangible evidence that our universe is just one of many in a vast, interconnected multiverse. Now turning to the 24th reason scientists believe in parallel universes, we delve into the profound philosophical questions that the multiverse theory raises. The idea of infinite parallel realities doesn't just challenge our understanding of the cosmos, it forces us to rethink the very nature of reality itself. If there are countless universes, each with its own set of physical laws and possibilities, what does that mean for our sense of identity and purpose? One of the most striking implications of the multiverse is how it reshapes our understanding of existence. In a single universe, we might see ourselves as unique with a fixed set of choices and outcomes. But in a multiverse, every decision we make or don't make could spawn a new universe where a different version of us exists. This raises the question, are we truly free to make choices, or are all possible outcomes already playing out somewhere in the multiverse? The concept of free will becomes deeply intertwined with the idea of infinite possibilities, leaving us to wonder whether our actions are truly our own or simply one thread in an endless tapestry of realities. The multiverse also challenges our understanding of identity. If there are infinite versions of ourselves, each living out different lives, who are we really? Are we defined by the choices we make in this universe, or are we just one fragment of a much larger, interconnected existence? This idea can be both exhilarating and unsettling, as it forces us to confront the idea that our lives might be just one of countless variations, each equally real and valid. Beyond identity and free will, the multiverse theory also raises questions about the meaning of existence. If every possible outcome exists somewhere in the multiverse, does that make our lives less significant or more? Some might argue that the existence of infinite realities diminishes the importance of any single universe, while others might see it as a testament to the boundless potential of existence. The multiverse invites us to consider whether meaning is something we create within our own reality or something that transcends all possible universes. These philosophical questions don't have easy answers, but they highlight the profound impact that the multiverse theory has on our understanding of reality. As we grapple with these ideas, we're reminded that the search for parallel universes isn't just a scientific endeavor. It's also a deeply human one, challenging us to reflect on who we are, what we value, and what it means to exist in a cosmos that might be far more vast and complex than we ever imagined. With these philosophical implications in mind, we move closer to the final reason scientists believe in parallel universes, where we'll explore the future of multiverse research and the potential for groundbreaking discoveries that could reshape our understanding of reality once again. Now turning to the 25th and final reason scientists believe in parallel universes, we explore the future of multiverse research and the groundbreaking technologies that could one day provide direct evidence for this mind-bending theory. The quest to uncover the secrets of parallel universes is far from over, and scientists around the world are pushing the boundaries of what we know about the cosmos. One of the most exciting areas of research involves advancements in quantum computing. These powerful machines, which operate on the principles of superposition and entanglement, could potentially simulate the behavior of parallel universes, offering us a glimpse into how they might function. While this wouldn't be direct proof, it could provide compelling insights that bring us closer to understanding the multiverse. Another promising avenue is the continued exploration of the cosmic microwave background, or CMB. Scientists are analyzing subtle anomalies in this ancient radiation, searching for signs of collisions between our universe and other bubble universes. These faint imprints, if detected, could serve as indirect evidence of a multiverse, offering a tantalizing clue that we're not alone in the cosmic landscape. The work of visionary scientists like Stephen Hawking and Brian Greene has also paved the way for future discoveries. Hawking's theories on black holes and the nature of spacetime have inspired new ways of thinking about the multiverse, while Greene's exploration of string theory and higher dimensions has opened up entirely new possibilities for understanding parallel realities. Their contributions remind us that the search for the multiverse is not just about answering scientific questions, it's about expanding the horizons of human knowledge. Looking ahead, technologies like next-generation particle colliders and space-based observatories could play a crucial role in uncovering evidence of parallel universes. These tools may allow us to probe the fabric of reality at scales we've never before imagined, potentially revealing hidden dimensions or interactions between universes that were previously invisible to us. The future of multiverse research is filled with potential, but it's also filled with challenges. Detecting parallel universes, if they exist, will require not only technological innovation, but also a willingness to rethink our most fundamental assumptions about reality. Yet, as history has shown, the pursuit of knowledge often leads to discoveries that transform our understanding of the universe and ourselves. As we stand on the brink of these new frontiers, one thing is clear: the search for parallel universes is far more than a scientific endeavor. It's a journey that challenges us to imagine the unimaginable, to question the nature of existence, and to explore the infinite possibilities that lie beyond the boundaries of our own reality. And who knows, the answers we seek might be closer than we think. Now, turning to the conclusion of our exploration, let's take a moment to reflect on the 25 compelling reasons scientists believe in parallel universes. From the mind-bending implications of quantum mechanics and the many worlds interpretation to the vast cosmic landscapes suggested by string theory and eternal inflation, the evidence is as diverse as it is fascinating. We've delved into the fine-tuning problem, the mysteries of dark energy, and even the philosophical implications of a multiverse, each theory offering a unique perspective on the possibility of infinite realities coexisting alongside our own. The journey through these ideas has taken us from the smallest particles to the largest scales of the cosmos, revealing how interconnected and complex our universe, or multiverse, might truly be. Whether it's the anomalies in the cosmic microwave background, the strange behavior of quantum entanglement, or the speculative yet tantalizing simulation hypothesis, each piece of the puzzle invites us to rethink what we know about existence itself. As we wrap up, consider this: if parallel universes exist, what does that mean for our understanding of reality? Does it challenge our sense of identity, free will, or even the uniqueness of our own universe? The search for answers is far from over, and every discovery brings us closer to unraveling one of the greatest mysteries of all time. If you found this exploration as fascinating as we did, don't forget to share your thoughts in the comments below. What do you think about the possibility of parallel universes? And if you're hungry for more mind-bending content, hit that subscribe button and ring the notification bell so you never miss out on our next deep dive into the mysteries of the cosmos. Thanks for joining us on this incredible journey. Until next time, keep questioning, keep exploring, and keep imagining the infinite possibilities that lie beyond the stars.